push two magnets together, and you feel a force with no string, no glue, no contact. Attraction or repulsion you can sense in your palm before your brain names it. Something invisible is arranging the encounter. That something has a diagram. At everyday scale, a magnet is one solid object. Zoom inside ferromagnetic metal, and you find domains, microscopic regions where electron spins team up like tiny bar magnets. A bulk magnet is a crowd vote on which way to point. Not everything sticks. Copper, wood, and glass mostly ignore a magnet's invitation. Iron, nickel, and cobalt have domains that can swing into alignment. Materials where magnetic teamwork is possible, not guaranteed. Every magnet carries a field, a vector map showing which way a tiny compass needle would point at each place in space. Field lines leave the North Pole, curve through air, and re-enter the South Pole. They never cross. They show the path of least argument. Bring north near south, and field lines shorten their loop through air. The magnets feel pulled together as domains, and nearby, iron optionally join the party. Opposites are a geometry that closes circuits efficiently. Turn two north poles face to face, and field lines get squeezed sideways. They must bulge outward instead of bridging, like compressing a spring made of arrows. The magnets push apart. Same force, different routing. In unmagnetized iron, domains point every which way. Their fields cancel. Stroke with a magnet or expose to a strong field, and domains nudge toward alignment. Enough agreement, and the piece behaves like one big magnet. Moving electric charge creates magnetic fields. Wrap wire in a coil, run current, and you build a magnet you can switch off. Every motor, speaker, and MRI borrows this trick. Electricity wearing a magnetic costume. Here is the twist. A permanent magnet is not one eternal force glued to metal. It is a material that remembers an alignment won against thermal jostling. Heat a magnet hot enough, and domains scramble again. Magnetism is order. Heat is the undo button. Planet Earth has a magnetic field from molten iron motion in its core, a dynamo on a planetary scale. Your compass needle is a free rider on that field, pointing roughly north because it aligns with Earth's external lines. Recap: magnets produce fields mapped by compass behavior. Domains inside iron can align to amplify the effect. Opposite poles attract by closing field loops. Like poles repel by squeezing lines apart. Current makes switchable magnets. Heat can erase the alignment. Next on Science Sketch, metal and wood in the same room, same temperature, yet metal steals heat from your skin faster. Cold is not always what the thermometer says.